in terms of to solve a specific problem. If you're doing it to solve, and it's a multiple choice, if you have to solve something using completing the square via multiple choice, why not just plug and chug and see which one works? The only problem is if you have imaginary solutions. So that's why you still have to understand these scenarios is which to complete the square. Now, I don't remember yesterday or not. I think first hour we did number 11. Did we do 11 with you guys yesterday? No. All right. You know, they're not terrible. They're a little weird, but they're not too terrible. I'm trying to make, in the idea of, if you think about the timing of the final, how much time we have for it, with only having 75 minutes and trying to hit a broad style of questions, I can hit a broad style of questions, but not overbearing you with god-awful numbers. So I'm trying not to make them awful. No, we'll call them awful light. That makes any sense? Yes, ma'am. I haven't made that decision yet. I haven't decided. So solving equations by completing the square. Remember, the first thing that you have, in order to be able to complete the square, you have to have one side, you have to have you can't have, I can't speak, you can't have a c value. So what we do is we take the 10x squared plus 20x we see your brother. I'm sorry. Tell him I said that to you. It's true though. No. All right. Anyway, so what happens here when we're I'm sorry, it was so bad. When you complete the square, whenever you complete the square, you cannot complete the square if your first term isn't equal to 1. So what we do is we factor out the leading term coefficient, and whatever we factor out on one side, you have to remember to put it back on the other. So now you go through the process. In order to complete the square here, we have 10. What is half of 2? So whatever you take half of, you drop down, you square it. What's 1 squared? 1, and you add it to both sides. Whenever you complete the square, you take half of b, and it drops here. When you square it, it goes there. Yes, ma'am. Yes. Yep. Always move to C first, because that's what we do with cogs. Always move all those first. Because now when you get it over to the other side, you get negative. We get negative 35. Divide that by 10, so we get x plus 1 quantity squared equals negative 35 over 10, otherwise known as negative 7 halves, I believe. And then when you go to solve that, you're going to have an imaginary root. Well, in this case, when you take the square root of that, we get x plus 1 equals plus or minus the square root of negative 7 over the square root of 2. We're going to write it as two separate pieces. Obviously, the square root of negative 7 is going to wind up as I root 7. The square root of 7, the negative 7 becomes I root 7. But then I have to rationalize my denominator. In order to rationalize my denominator, I have to multiply both the top and the bottom by the same thing, some factor of 1 that eliminates the radical in the denominator. So I multiply by root 2 over root 2. So my final solution here is, well, I get x equals negative 1. All I do is move the 1 over. Plus or minus I root
14 over 2. What did it have? Oh, you know why? Because they got a common denominator. They got a common denominator. Notice how their answer has it all over 2? I only have this portion over 2. They wrote it as a common denominator by putting the whole thing over 2, so you get negative 2 plus or minus I root 14 over 2. It is the same answer. Normally, whenever I rationalize and leave it like that, whenever I have that fractional part, I'm usually just going to leave it like this, okay? Yeah, exactly. And you might, if you see something like that again later on, look and see if the fraction bar goes completely across the whole thing versus just that last half of the radical. That's a very common thing for some answers to do. This technically is more correct than that, but I'm cool with that. All right. So why did we complete the square? Yeah, because I told you to. In other words, we did that so we can work with conics. Oh, solving by factoring. If it's a solve by factoring, that means find the zeros, or if you had to, you would factor stuff, or would you just press buttons and calculate? Exactly, depending upon how it's asked. Okay, especially if it's multiple choice. If it's multiple choice, what would you do? Plug and chug. I wouldn't waste my time with anything. Excuse me. Solve by taking square roots. You guys remember to take square roots? You don't just take the square root of how it's sitting. You actually have to do some math first. (7x squared equals negative 101). I added 1. Divide by 7. Divide that by 7. What do we get? What is that? Oh, that's a crappy fraction. And then you're going to get x equals plus or minus the square root will be I root 101 over root 7. So it'll be plus or minus root 707 over 7 with an I in it. That's really gross. Super exciting fun time. Oh, yes, indeed, it's fun time, fun time. In the song. Nope. Better musical taste. Solving equations via the quadratic formula. Hey, Nina, what do you do to move the 49? Subtract it. Very good. I know, exactly. Am I serious? What happens if it just says solve? What happens if it does that? Yeah, but what happens if it just says solve? They just solve it. I know, but remember, there's more ways than one to get through some of these. If it says solve the quadratic formula, if it's the written part, then you got to use quadratic formula. That's a good question. That's great. So let me ask, can you just write down the quadratic formula and solve the other one? Like, well, doesn't that, if I'm telling you to solve via the quadratic formula in a written portion, doesn't that seem kind of, it's lame. All right. Identify vertex, axis symmetry, direction of opening, max min of each value. Now, this is getting back to the quadratic stuff. How do you do this? Well, there's depending upon what is being asked and what portion is being asked. If it asks you for the maximum or minimum or just where is the axis of symmetry, a lot of times you could get away with figuring this out relatively quickly without having to worry about calculators or anything. For example, This is what we call intercept form. When you have two terms put together, you're able to figure out where your zeros are located. So in this case here, you have zeros that are located at 1 and 9. We know that you have zeros located at 1 and 9, and where is the axis of symmetry? It's in the middle. It's going to be at 5. So your axis of symmetry is located at x equals 5. And the reason that happens is because it's, you add them together and cut it in half. Because your zeros, the axis, or your zeros will always be equidistant to that imaginary vertex, or the imaginary axis of symmetry. I say axis of symmetry. Now, that also means that somewhere along the axis of symmetry is going to occur your vertex, which means the x-coordinate for your vertex is going to be 5. So what do you do to figure out the y value then? Yep. So if you do that, you get 5 minus 9 and 5 minus 4, and you get negative 16. If it's at negative 16, what direction is this opening? Up like a... Wait to see what you would say. Yeah, remember yesterday it was down. You said down like a cup. And there you go. Okay? Which means that vertex, is that vertex a maximum or a minimum? It's minimum. So let's say you completely forgot how to map that. What are you going to do? Substitute it, put it in the calculator and hit some buttons and figure it out. Okay? What's that? How do you map it? Put it in the calculator. Exactly how it is. No. Same thing with number 20. If you forgot what that format looks like, go,
I know on my calculator, there's a button that says that. So, can I just figure out what it is?
yes, you can. I was joking. It was just the first thing that came. I don't know. I'm just making stuff up. It's one of these days. 8y equals, and if we put that in, if I move the 7 over, we have the quantity of what, something? X plus 4 quantity squared minus 7? X plus 4 quantity squared minus 7. What? Ooh, fancy schmancy, isn't it? Yes, ma'am. You can put wherever you want. It just so happened that's the one I was happen to be in. Okay. I felt kind of red today. What? Anyway, so at this point, then you can hit your second calculate. That's a minimum. Move to the left of the vertex. Eventually, to the right. I now have a vertex at -4, -7. Pretty sure you're going to be okay by noting that it's going to be at -4. Axis of symmetry is at x equals -4. That's true. I feel bad this is the last one, so I'm sorry. And then your zeros, you hit second, calculate 0, and do the same basic idea. Calculator is your best friend sometimes, as long as you remember how to press button. Make sure you charge these, guys. Make sure, like on Tuesday before, or no, Wednesday before, no, Thursday. One of those days next week. So it's next Thursday before you go home after your finals. Stop in, throw your calculator in a charger so that when we come in on Friday, you can use it. It's charged up. It's difficult to take the batteries out of this one to rub them in your hair to charge up static. Oh, I don't know. This is one of the ones I'm still kind of toying with. Yes, ma'am. Everybody but you now. Conics, you're so much fun. Conics. I was explaining with this to the first hour is that if you go back to when we did conics back in late October, early November, we also had a couple style. I gave you guys, I think, a couple different review sheets that did have some conic stuff with multiple choice as well. Not a bad idea to go back and revisit a few of those. When you're taking care of conics and you're working with those, what you want to do is set all your x values together, your y values together, and move the constant. Yes, sir. Yeah. So here you've got 25x squared. Oh yeah, you can't. Sorry, you're gonna get arrested. He walks out the door, click, click. No! And he's sort of, no! You hear the whole Doppler thing. Devin, the high school is weird. Oh, it's answering your son. Devin, high school is weird. Yeah. You okay, buddy? All right. Air 5, Devin. Yeah. All right. So when we go to complete the square with conic stuff, we do the same thing, guys. You want to regroup your x's and your y values. So I'm going to take the 25 out of the x. Then I'm going to take out the 16 out of the 64. In order to complete the square, you always have to have first term. First term is always going to be equal to 1. Now, if I took 25 out on one side and I took 16 out on one side, what do I have to do to the other? Yep, very good. Got to put them back. So we're going to have it's going to equal 111 plus 25 times something plus 16 times something else. Or it could be the same something. I don't know. And now I go through the process of completing the square. Whenever I complete the square, I'm going to take half of my b value, and that always drops into my parentheses. So we're going to have 25 times the quantity. Well, what's half of negative 6? Negative 3. Very good. When I square that, what do I get? 9. So 9 goes up here and over there. Pretty sure you're right. I'm not right. Same thing with the 4. What's half of 4? 2. When I square it, what do I get? Okay. Did you guys notice that I didn't worry about my signs there? I kept the signs, whatever the b value was initially, I put that into the square terms. That's how it's always going to work. It's always going to work that way. So now we have to figure out what 25 times 9 plus 64, or 16 times 4 plus 111 is. Hey, guess what? It's equal to 400. SMRT. Hey, and guess what happens when you divide out by the 400? You're not crying. You're going to get x minus 3 quantity squared over 16 plus y plus 2 quantity squared over, guess what? 25 is uno. Now I'm looking at my conic sheet, deciding whether or not it's a circle, hyperbola, ellipse. Why don't I care about it being the parabola? No, because they're both squared. Yeah, they're both squared. Okay. Remember, parabolas will have either an x squared or a y squared only term. So this one's going to be an ellipse. And when you're looking at the rules for ellipses on your calculator, if you look at the rules for ellipses, see how the a value switches? Where does the a value go for ellipses? Remember? Which one's the a value? the larger one. It's hyperbolas that's the first one. And the way that you'll be able to tell that is because watch what happens when you look at the hyperbola one. You look at the hyperbola question, notice how the a values come first? What switches there? The x's and the y's. Okay. So by having that now, but what's going to be nice though is that you won't make that mistake on the test because you're going to have that sheet directly in front of you. So you'll look at it and go, oh no, it's not because it switches. Then you remember, okay, it's got to be bigger than 2. So you'll be able to not make that silly mistake. Right. So going back, knowing that we have an ellipse, I think, with an ellipse with an a squared value underneath the y, that means it's going to be stretched up and down. Correct. So let's see, we have a center. Our center is going to be located at 3, -2. And our a squared is 25. Our b squared is 16, which means our c squared is going to be how much? Which is? It's nice when it works out cleanly. You get the c value. The c squared is always going to be, it's going to be the opposite when you're dealing with the sign between the two fractions. So if it's an ellipse, the c squared is going to be found by a squared minus b squared. And if it's a hyperbola, it'll be plus. So now you have your a value. Now remember, these values never change. A is always from center to vertex. B is always center to co-vertex. And C is always center to focus. Okay? That will always be the case, whether it is it's an ellipse, whether it's a hyperbola, or whether it is a parabola. The only thing that's different with the parabola is that with the parabola, you don't have A's and B's and C's, you have the p-value or the directrix. I'll do one of those here in a second. Now it's just a matter of plotting points, and in the essence of time, do I need to plot points if we remember where the things go? All right. I'm going to skip ahead to the next one. I think the next one is a y squared only. On the sheet, I think that's going to be just our straight parabola, if I'm not mistaken. Yeah. 24 is giving me a y squared parabola. Everybody see that? So I know that this has to be a y squared parabola. So when I look at my calculator, I look at the equation in generic form for a parabola, I'm going to get this quantity y minus k squared equals 4p x minus h. So we have to, what's that? Right. Because there's only one of them is squared, and the one that's squared is y, so it has to be the y squared. And if I'm not mistaken, the y squared parabola either goes left or right. So what's going to determine what direction it's going to go is going to be the value of p. Okay? If p is negative, I'm going to open left. If p is positive, I'm going to open to the right. So we have to set up to complete the square just like we have been. We're going to get y squared plus 6y plus blank equals negative x minus 14 plus blank. What I did there was I just kind of skipped one small step as far as setting up the complete the square portion. I put in those blanks first without really doing anything. And now I complete the square. What's half of 6? 3. So in my term, I'm going to get y plus 3. Quantity squared. When I square 3, I get 9. So then I get, on the right-hand side, I'm going to get negative x minus 5. Oops. It's very close now to what we get for the x minus h within parentheses, but what do you have to take out? Negative 1. Very good. Remember, the rule was whenever you had that stuff on the right-hand side that wasn't squared, you always factor out, no matter what number it is, if it's 6, 8, negative 1, you always factor that out. You could get some crappy fraction for the other part, but it's okay. But you factor that out because then that's what you're going to set equal to the 4p to figure out what your value is. So we get y plus 3 quantity squared equals negative 1 x plus 5. Which means 4p equals negative 1. P is negative 1/4, and you're right, it's going to the left. The center is still going to be located at HK. In this case, my center is going to be located at negative 5 and negative 3. Now, I will tell you one thing. If this is a multiple choice question, I guarantee the center will also be written at negative 5, negative 3. Because the center would be at negative, I'm sorry, it would be written backwards. It would be written at negative 3, negative 5. Because remember when we did that conics test, when we had something that was flipped backwards? I think it was a hyperbola question that gave you guys with y squared first. You guys did your center flipped into the wrong quadrant because you forgot. The p is going to be the distance from the center to the focus. So when I graph this out, I'm going to be at negative 5 and negative 3. There's my center. The p-value means that we know it's going to have to open to the left because it's negative. So the focus is just moved over a fourth. What's a fourth more to the left of negative 5? Yeah, so your focus would be at negative 5 and a fourth, comma, negative 3. This is an example of when a mixed number is just perfectly workable and fine. You don't have to really worry about it. And then when I put my directrix in, your directrix is going to go the other direction a quarter, and it's going to be a vertical line. What's a quarter to the right of negative 5? So your directrix would be at x equals negative 4 3/4. Okay? No, they said that you need to go down to the office because they found cocaine in your locker. Yeah.
Hey, by the way, Mr. A. Bedford, I need you to come down to the office. Lockhart has a jump seat for you as well.
Yes. No, it said there's an ice cream party downstairs. If you're not there in 2 seconds, it's all gone. Huh? How'd I get what? Directrix? So remember, the focus, the p-value is always the distance from your center to your focus. The p-value, it being negative, meant it has to go to the left because we knew it opened that direction. So that's why I basically subtracted a quarter. When I go to the right, I have to add a quarter. Equidistant to the center. It just so happens to be weird because you have a quarter as opposed to it being like 6. So other than that, it works out cleanly. Who's not going to be here on Tuesday? So that's a Y, that's a Y. All right, let's run through this one real quick. Since we're cranking along on conics, we might as well. In this case here, you don't have to do anything with x, which is nice. So what I'm going to do, since I know I don't have to worry about it, is I'm going to immediately write it as x minus 0 quantity squared. The reason that I'm doing that is because now I know that my h value is going to be located at 0. So now and then I get the negative 1 y squared plus 4y plus blank is 13 minus 1 times something. And the reason why all I did there was I just skipped an extra step of rewriting with the
negative there. And then you're always going to have to factor it out to get to complete the square, so I thought I would just save myself, running low on ink this time of year. What's half of 4? 2 squared is? Oh, sorry. Let me go ask somebody, what's the log base 3 of 3? The answer is 1, knucklehead. Oh, hi. Is it June yet? Wait, we're done in May. Never mind. Isn't the end of May yet? Hey, 8 Mondays, spring break. 8 Mondays till spring break. Just remember that. No. 8 Mondays. Find everything out by 9. In this case here, you wind up with a hyperbola. We get a hyperbola in this case, guys. And the reason that's a hyperbola is the subtraction symbol. It's an x squared hyperbola, which when you look at our calculator, I believe x squared hyperbolas go up and down. I'm guessing I don't know. That's why I need the cheat sheet. I was wrong, they go left and right. It's up and down if you're laying sideways. And then it's a matter of, when you're working with these, if your a squared is 9, your b squared is 9, your c squared is 18, and then go from there. Working off of this one is really clean because of the fact that you've got whole numbers. When you have a hyperbola, you add them. So our center is going to be located at 0 and -2. Our vertex is going to go left and right 3. Co-vertex up and down 3. And then I have to make my rectangular box. Oh, that's it's really nice. What's your slopes going to be on these? Yep, -1, because you went up 3 and over 3, so the slopes are really easy there. Rise over run. I went. No, it's M, not O. I'm sorry. I'm sorry. What? Your A value is going to equal ±3. Your B value is ±3. So it's your distance from your center. From your center to your vertex is always your A value. Your center to your co-vertex is your B value. So from there, I'm just walking up and down 3. It just works out that it winds up being squared. The C value is your center to your focus. Now the square root of 18 is what? 3 root 2. So that's a little bit more than 4, but it's less than 5. So here's 4 and 5, so it's somewhere here-ish and somewhere here-ish. Now, writing out the ordered pairs for all these things are going to be relatively easy, but remember when you write out for the focus, when you do the roots, all you have to do, and I'm just going to write that one out, the focus is that we know that it's going to be, we took our center, which was -2, and we added 3 root 2. I'm sorry, it was 0 plus the 3 root 2 comma -2, and 0 minus the 3 root 2 comma -2.
That's where our focus was located at. And I'm leaving it as 0 plus that, 0 minus that, because sometimes your center is located at 1, and you just have to add them. Yes, sir. Because we know that the equation itself told me that it's an x squared, which means it opens left and right, and your curves always open to the left. Just looking at that. And going from there. Equation of the line. If we have the equation of the line here, you know that we found the slopes it was rise over run up 3 over 3. And if we had to write the equation, we have our slope at plus or minus 1. And we'll just use the ordered pair, which happens to be a y-intercept, isn't it? The y-intercept is at -2. So your equations are going to be y equals 1x minus 2 or -1x minus 2. The equation of the asymptotes. Oh, I don't know. We did it. I try to put as much in there as I possibly could. Nothing. I just wrote the equation real quick. The equation of the asymptotes. One of the things that I'm going to do over the weekend is I'm going to finalize everything. So when we get in here on Tuesday, I'll give you guys a really good rundown of exactly what to expect, and then we're going to bum rush through the rest of these things. Yes, sir. Left and right. Formula sheet tells me it's going to go left and right. Why would there be snow day? What they're doing here is they're trying to alleviate the possibility in case, God forbid, something does happen. We're still having finals next week, Wednesday, Thursday, Friday. Okay? We'll still have finals Wednesday, Thursday, Friday. Yes, ma'am. You know it's a circle. You will know it's a circle if, what was the example? I don't remember package 2 had it. I think I put one on there that was a circle. You know it's a circle if it's plus between the two and the A and the B values are the same. Yes. It'd be the same value if it's minus. That just gives you the square for where the hyperbola is going to go through, versus if it's an ellipse and it's the same values, then it has to be a circle, because then your vertex to co-vertex and your center to co-vertex, center to would all be equidistant, which creates a circle. I don't remember off the top of my head. Yes, ma'am. Yes. Yes. One of the things I did want to, when I got into things like this where it says find all roots or solve for all zeros, find all zeros. Remember, guys, finding all zeros means literally finding the zeros. It's a third-degree polynomial. You should have 3 zeros. It does not mean list all possible. If it says list all possible, it would say state the possible rational zeros for the function. That's when you do all those plus minuses. That was a confusal thingy earlier in the days. Okay. Try and get through as much as you can. Have plenty of questions and ready to go and games and stuff. Hey guys, go sit down. You got another 3 minutes here. Come on.